we are going to be doing a quick review on how to add and subtract polynomials. So this is really just adding like terms. That's what we're doing here. So in number one, we have two polynomials that we're trying to add together. Each polynomial is in parentheses. If you have parentheses, your goal is to get rid of them, usually by distributing. If we were to distribute here, this positive, there's not a number, so it's understood to be a 1. If we multiply by -1, it doesn't change the value of what's already there. 1 times 4x cubed is still 4x cubed. 1 times 8x squared is still 8x squared. So distributing a 1 does not change anything. So in these situations where it's just adding, you can drop the parentheses and ignore that. So 12x squared plus 9x minus 21 plus 4x cubed plus 8x squared minus 5x plus 20. At this point, you want to try to find like terms. So we look for the highest exponent first so that we can write our answer in descending order. Descending order means your exponents go from large to small. So the highest exponent that I see is a 3. I have a 4x cubed, so I want to write that one first. It doesn't have any like terms, so I'm going to write it down. Next, I want to look for an exponent of 2. I see that I have 12x squared plus 8x squared. Since those are both x squares, those are like terms. To add those, you simply combine the numbers in front, the coefficients, and leave the variables the same. So 12 plus 8 is 20, so I'd have 20x squares. Okay, next I want to look for the x to the first power, which is just x. I have a 9x and a -5x. So 9 minus 5 is 4, so I would have 4x. And then the last thing I have are the constant terms. So I have -21 and +20, and when I combine those, -21 plus 20, I get -1. Notice that I have no like terms now. So I've combined all my like terms, and that's all I want to do. So I'm done. Number 2, similar, but in the middle we have a minus, a subtract, instead of a plus. If we put a 1 here, that's helpful for some people, and we think about distributing or multiplying through by a -1, that will change what's in the parentheses because it changes the sign. A negative times a positive is a negative. So instead of having 5x cubed, we'll have -5x cubed. A -1 times a -2x squared, the two negatives make a positive. So instead of having -2x squared, we're going to have +2x squared, and so forth. So for the first set of parentheses, we don't change anything. We just bring everything down. In the second set, we distribute that -1 by multiplying, and we will get -5x cubed plus 2x squared minus 3x and minus 2. Now we're going to look for like terms. Now that we have our parentheses all gone, we've distributed, we look for like terms. I see x to the 4th is the highest exponent. There's no like terms with that, so I'm just going to bring down the 7x to the 4th. Next, I want to look for x cubed. I see a -5x cubed. I don't see any other x cubed term, so I'm going to just bring that down. So -5x cubed. Then I'm going to be looking for the x squared terms. I have a -x squared and a +2x squared. So that's like a -1x squared. It's understood to have a 1 coefficient. So -1 plus 2 is +1. So plus x squared. Then I'm going to look for the x terms. So I have 6x minus 3x. That will give me 3x. And finally, I have my constant terms. So I have +1 and a -2, and when I combine those, I get -1. So there is my polynomial. Okay, number 3. Now I have 3 polynomials that I want to combine. I have an addition sign between the first two, and between the second two I have a subtraction sign. So I'm going to be distributing the negative, meaning multiplying through by a -1. So the first set of parentheses does not change. I can drop the parentheses without changing anything. Since I have a plus in front of the second set of parentheses, I can also just drop those parentheses. It doesn't change anything when I multiply through by a +1. But in the last set of parentheses, multiplying through by that -1 would change all of the signs. So I'm now going to bring down a -m², a +3m, and a -10. Now that I've gotten rid of all my parentheses, the next step is to look for like terms. So I have a -5m⁴. That's the highest exponent that I see. It does not have any like terms, so I bring down -5m⁴. Next, I'm going to look for x³ terms. So I have -3m³ and a -8m³. So I'm going to say -3 plus 8 is +5. So I'll have +5m³. Next, I'm going to be looking for the m² terms, and I actually have 3 of those. So I have a -m², a +3m², and another -m². Remember that if it doesn't have a coefficient written in front, it's understood to be a 1. So -1 plus 3 minus 1 would give me +1m². I only have one m term. That's a 3m, so I'm going to bring that down. And then my constant terms, I have a -5 and a -10, and when I combine those, I get -15. So I've combined all of my like terms. So there is my final polynomial. My final example is number 4. So we have a subtraction sign in front of the second and the third polynomials. So I'm going to start by distributing that negative to get rid of the parentheses. The first set of parentheses, I can just drop those and bring down everything inside. So we will have 15y³ minus 3y plus 1. Distributing that negative, I will get -8y² minus 13y³ plus 5. And then distributing the second negative, I will have -3y³ plus 5y⁴ minus 2y² and minus 8. So I want to look for my highest exponent first and then combine like terms. Again, I have a 4 power, so y⁴ will go first. So 5y⁴. Next, I'm looking for y³s. I have 15y³ and -13y³ and a -3y³. So that will give us -1y³, so we can just say -y³. Let's see, next we're going to look for the y²s. So we have -8y² and a -2y². So when I combine those, I will get -10y². Then we'll look for the plain y. So we have -3y, and that looks like the only one. So we'll bring that down. And finally, we're at the constant terms. So we have 1 plus 5 minus 8 would give us -2. And that would be it.